little lemma. Start important. Make sure it's something of value. Don't make it something trivial because, and I've seen this in some of the companies that we've worked with where they will do a POC, and they'll use one of the traditional foundational models and they go, oh, this is great. It's getting the results I want without understanding the business problem that they're trying to solve in totality. That if they actually even did something as costing this out, they would realize what might work on in this little trivial thing is going to cost them 20 million, literally 20 to 30 million dollars to implement in the real world. And it makes no sense because their budget is a $500,000. You have to be
Yeah,
thoughtful about it and do the right type of small project to get the right results.
I think that's a very good addendum to our start small principle. And I think you're right. It's sometimes the fact that a project is small can lead people to think that it doesn't matter then if the cost of doing a project is low, why don't I just loosen up the controls and let anybody that wants to do a small project do a small project? And as you said, you run the risk of creating projects that have no value to the business or that have an undeterminate value, or projects that look like they're interesting but actually couldn't scale. Maybe they're too expensive to run at scale. Um, we saw lots of cases in the early days of generative AI where companies were standing up chatbots that were customer facing chatbots. And obviously we all saw the news stories about the chatbots giving erroneous or inflammatory responses. But the thing that flew under the radar a little bit was what was just as big a problem was that the companies that did this didn't fully understand the costs of running the solutions the way they built them. And
Right.
they were turning on chatbots that might cost them, in some cases, $2, $3, $4 or more per customer interaction. And if you had hundreds of thousands of customers trying out your new chatbot the first month, you suddenly had millions of dollars of unplanned cost
Right.
associated with this small project that maybe only took someone a couple of weeks to develop.
Right. And I encountered a couple of these as well where, um, those not deeply in knowledge, don't have the knowledge of how these models actually work and what they did. They ran some simple test cases for smaller companies, and the results came back okay. With they thought it was promising, and just a simple the back of the napkin calculation, based on something like token counts. And I said, look, you take token counts and you calculate the cost for one of the providers out there, one of the cloud providers, and you rapidly realize what you're proposing is going to cost 15, $20 million each and every single run. That this is economically unfeasible. And I
Yep.
think, and I want to make a little bit of a plug here for you and me both, because we do teach a class, and I think a lot of the information that we're speaking about, a lot of this background information is extraordinarily important to making the right decisions when it comes to using AI effectively in a business and having a certain working knowledge of these models and how they operate for business users is incredibly important to making the right decisions.
Yep. Thank you for the plug. And thank you for the masterful segue into item number 5 on our list, which is model the costs. Know the costs of your solution and model how it's going to grow as the solution grows. So let's talk about cost modeling and how that works.
So you and I take a very engineering approach to, I think, a lot of these things, which is when we take an engineering approach, but with also the business experience. And I think which there is always constraints on when you solve a problem. And I think and I will say we aged here a little bit. You and I come from an era when there was some real practical constraints on the capabilities of the tools that we were using and memory and everything else. You were working on a computer that had maybe, I don't know, 4 gig of memory at the time for a large computer. Had very little power. So we were very aware of the constraints when we coded. We knew what the capabilities of the machine were and how far we can push it. I think today that's kind of gotten away from a lot of developers, and because for all intents and purposes, using the cloud appears to be horizontally scalable, computer scalable. It's not free; it's just scalable. So they don't model out there, and I've seen a lot of developers do this. They don't model out that big constraint cost, and that is the number one constraint. The customer comes to us and says, I have a $200,000 budget. Well, that's going to make it very different than a customer that says, maybe I have a $10 million budget, and how I approach and try to solve that problem.
Yeah, that's a really key point. And I think, for people who haven't implemented these in a corporate setting, a lot of people are familiar with the fact that you could pay, $20 a month or some similar fee to get access at a personal level to
Right.
a large language model. When you start doing this at a corporate level, because that $20, whether you've ever hit the limits or not, it comes with limits. There are limits to how many interactions you can have per day and how
Right.
much context you can provide and things like that. When you do this at a corporate level, you are paying by the drink. You are paying, technically, most hosted models are charging by the token. Let's
Right.
consider that a word. And those words include all the words in your questions, all the words that get generated in your answers, and all the words that are part of the context that you provide. And so, Peter, to your point, that word count goes up pretty quickly. And it's a
Right.
fraction of a cent per word if you look up the listed prices. But
But
those words add up very quickly.
you might sit there and upload a PDF, not thinking twice about it, or you might upload 5 PDFs. Maybe you're doing some analysis on a company or some research on a company, and you pull up all the SEC documents. So you pull up, 6 years of, 10Qs and 8Ks and 8Qs, and you upload them into your model. All of a sudden, you're using 500,000 tokens, not even realizing, and you haven't even asked the question yet.
And this is how companies got into a situation where, they could test for pennies an AI chatbot that was customer facing. But when you multiply that by repeated interactions with a chatbot and scale that out to thousands or tens of thousands of customers, suddenly what looked like a negligible cost became a substantial cost.
Very quickly. And so you might say, well, how do I make this less expensive? How do I figure this out? What do I do? And there are obviously solutions to making this less expensive. And um, and then these are none of which are particularly easy answers, but there are ways of making it less expensive. But it goes back to engineering a solution, understanding the problem you're trying to solve, understanding how much you want to scale it out, how many people are using it, the complexity of your model, what kind of response time you're looking for. Are you looking for 1,000 people using it concurrently or 2 people using it concurrently? Understanding all of these things are imperative to really modeling out the costs, to get a grip or a handle on what it's going to cost you to run it in an
Yeah.
environment. And I think keeping in mind, and then I'll stop talking, is the training aspect of it is a cost, but that in some sense is a finite cost. What really drives the costs up over time are the inferencing costs. And I think we can't forget that, but that's really where the costs are.
And the inferencing costs are the cost of people using the model, people asking
Right.
questions and getting answers back. Yeah, I think that's a really good point. There is definitely a trade-off between spending cost up front to configure and train and fine tune a solution versus cost on the back end. And if you look at our examples earlier on using context, it costs very, very little to introduce context into a model in terms of upfront setup time and cost. But you are paying a lot more when you introduce that
Right.
context. You're paying a large per token cost at use time or inferencing time.
Right.
Retrieval augmented generation costs more to configure, but one of the side benefits is you are presenting a more carefully selected subset of your context to the model, and therefore you could be lowering your inferencing costs over time because you're not giving it all of your context. You're giving it a select subset of context for each individual interaction. And then fine
Right.
tuning is, maybe the other extreme where you're spending much more upfront time and hours and associated costs with fine tuning a model, but you don't introduce as much context into that model. And in some cases, it means that you're not paying by the drink for inferencing. You're simply paying to host a model somewhere, and
Right.
you have, more, not quite unlimited, but you have less constraints on how much you use the model.
Right.
I think the important part is there will be for every use case, and it goes back to what you said, Peter, about having an engineering view. There will be a number of inflection points where at a certain level of usage, number of users, number of queries, amount of
Right.
context, etc., at a certain level of usage, it will be less expensive to take a different approach. And
Right.
understanding and predicting where those inflection points will be and monitoring your costs is absolutely essential to prevent this from being like a runaway cost scenario.